In section 1.3 we're working with functions. Remember, a function, every x value has exactly one y value. So if we're given our domain and range and we're told that this maps out this way where 0 goes to 0, -2 goes to 4, +2 also goes to 4, that'd be something like a parabola. And here every x value does have exactly one y value. So yes, this does show us a function, or if we do a vertical line test here, this also shows us that this would be a function. Now we might have something for our domain and range where we have values of -1, 0, and 2. Maybe the 1 is mapped to a 3, 0 goes to 4, and 2 goes to 5 and 6. Has two different values that it's mapped to. This would then show us that no, this is not a function. We have the 2 that has two separate values it goes to. If we're looking at a graph, again I mentioned the vertical line test. If we have something coming along like this, it's fine until we have something here. If I do a vertical line test along here, we see that it intersects this graph in more than one place. So again, no, this is not a function. Now if we're given a function f of x is equal to 2x cubed minus 5x squared, and we're asked to simplify or evaluate these. If we're given f of 3, what we do then is we plug in 3 for x. So on this example we would have 2 times 3 cubed minus 5 times 3 squared. 3 cubed is 27 and 3 squared is 9. So now we have 2 times 27 minus 5 times 9 gives us 54 minus 45. So f of 3, when we simplify, would be equal to 9. Remember, that's just like having an ordered pair. 3 is our x value, 9 is our y value. Now if we're given something here where we need to simplify, and we're going to find f of the opposite of x, same idea. We're going to go to our function. Now we have the opposite of x plugged in here. That's cubed. And here we have the opposite of x, and that's squared. Now when we take the opposite of x cubed, then we're going to end up with still having the opposite of x. That x is still cubed. So this would give us -2x cubed. And here when we take the opposite of x and we square it, that just gives us x squared. So then we still have the -5 times that, so minus 5x squared. So then the f of opposite of x is equal to -2x cubed minus 5x squared. Another part of this section, we're looking at domain, our x values. Now remember, we basically have two rules that we always need to check when we're looking at domain. First one is that we're not allowed to divide by 0. And the second one is that we have no negative radicals. So if we have something like f of x is equal to x squared plus 2, no divided by 0, no negative radicals. Here we have x squared. We don't even have a fraction. We don't have a radical. So really there's no restrictions on this domain. We could be talking about our domain being all real numbers. So we could write that as -infinity to infinity to go there. If we're looking at something like f of x is equal to square root of 1 minus x. Alright, so here, again, no fractions, so we don't have to worry about dividing by 0, but we do have to look at what if we have a negative radical. So what we cannot have here is 1 minus x cannot equal 0. It's going to have to be greater than or equal to 0. And now we solve for x. First we subtract 1, so now we have the opposite of x is greater than or equal to -1. Then we divide by -1, multiply by -1, change the sign on both sides. X is, remember to change this sign as well, x is less than or equal to 1. So then again, we can show our domain to say that x is less than or equal to 1. So to show that, we're saying that we're going to go from negative infinity to 1, and if we put the bracket, then that's going to include that value because we're saying that it is equal to 1. Let's say that we have f of x is equal to x divided by square root of x minus 4. Okay, we have a couple different things that we're looking at here. First of all, we can't have 0 on the bottom of our fraction. So we're going to say that the square root of x minus 4 cannot equal 0. What we really need to look at there is that the x minus 4 cannot equal 0. So if we just solve it for x minus 4 equals 0, add 4 to both sides, so we're going to say x cannot equal 4. The other thing we would want to see is because of the radical x minus 4, since we can't equal 0, we're going to say that it's going to have to be greater than 0. Again, add 4, so x is greater than 4. So again, when we're writing this, we would use parentheses because the 4 is not included, and we're going all the way to infinity. So x is greater than 4.